Namaskar. I am Rudra Kafle from Worcester, Massachusetts. This is Physics is Fun, Episode-5, भौतिक विज्ञानको रमाइलो भाग 5. आज हामी, as I announced in my post, that today we will be learning vectors. Vectors are very important quantities in physics. Vectors, there are various vector quantities. I'll talk about those in a few minutes, right? So what are vectors? Okay, so we'll do some experiments, simple experiments. So you will be doing experiments with me. Okay, so if you are small children, please take help from your parents or seniors. Okay, so before I start, I would like to ask one question which we already learned. So I have an apple in my hand. This is an average size apple. So do you remember what is the weight of this apple? What is the weight of this apple? Let's give a couple of seconds. So the weight of apple, an average size apple, is 1 Newton. Okay, the weight, what is the weight? Weight is the force with which this object is pulled toward the center of the earth, on the surface of the earth, right? So the weight of this apple is 1 Newton. Okay, so what is the mass of this apple? The mass of this apple is, do you remember? Do you recall? How much is that? The mass of this apple is 100 grams. So that is what we call CGS unit, grams, right? Let's divide that by 100. Sorry, let's divide that by 1,000, right? Because 1 kilogram has 1,000 grams. So if you divide 100 by 1,000, so this is 1/10, 0.1. In decimal, 0.1 kilogram. So we know the mass of this object. We know the weight of this object. Mass of the object is 100 grams or 0.1 kilogram. Weight of this object is 1 Newton, right? So there are two quantities we are talking about, and they are very important. There is a very important difference between them. That is, one quantity is a vector, other quantity is a scalar. Which one is a vector? 1 Newton force, we call 1 Newton force, and we call 0.1 kilogram mass, right? 0.1 or 100 grams mass. So how do we make the difference? How do you understand the difference? For example, the weight of this apple is 1 Newton. So this is incomplete saying. This is incomplete specification. How do we complete that? 1 Newton towards the earth. 1 Newton towards the earth. But in everyday life, we don't say that. In everyday life, we don't say that. Okay? So while writing, we need to specify this kind of quantities, giving the correct direction. The weight of this apple is 1 Newton toward the center of the earth. We are used to, so that we don't say that. But we need to be careful. 1 Newton, the weight of this object, which is the force with which the earth, this object is pulled by the earth towards the center of the earth, right, is 1 Newton here, in this case, the weight of the apple. On the other hand, mass, 100 grams or 0.1 kilogram, so we don't need to specify the direction. It is already completely specified. Okay, so we would like to distinguish between these two in today's class. Okay, so now I would like to pose a question, and by the end of this class, if you become comfortable to answer my question, I would be happy. I will think that my class is successful. So what is this question? The question is, so I have Einstein here, Albert Einstein, little Einstein. I got a gift from American Association of Physics teacher, right? So I have Albert Einstein here, mini Albert Einstein. So I'm asking you a question. So now at this point, you know how much is 1 Newton force. So imagine that Einstein is pulled that way from its back, right? Let's consider west, east, south, north, right? Let's consider the direction that way. Suppose Einstein is pulled towards south with 1 Newton force. Einstein is pulled towards north by 1 Newton force. Einstein is pulled by 1 Newton force towards west. Einstein is pulled by 1 Newton force towards east. So how many forces? 4 forces, right? There are 4 forces. 1 Newton force, that means 4 forces are acting. 4 forces are acting on Einstein now. What are those 4 forces? 1 Newton towards north, 1 Newton towards south, 1 Newton towards east, 1 Newton towards west. So I would like to ask you, what is the net force on Einstein? What is the net force on Einstein? So while I was doing teacher training in Massachusetts, I asked this question and I found very interesting answers. Okay? So please think about this. Please think about this. So what is the net force on Einstein? 1 Newton force towards south, 1 Newton force towards east, 1 Newton force towards west, 1 Newton force towards north. What is the net force? So probably, okay, let me give you a couple of seconds. Please think about that. Okay? But a bit more challenging question is this. That might be a kind of easy for you. Okay? If you are a little children, please ask your parents or seniors around you. How much is the net force? Or you can tell them the answer. Try. Okay? Please try. You can make a mistake. Don't worry. You can make a mistake. Please don't worry. That's how we learn. Okay? So now the next, even more challenging question is this. A more challenging question is this. On the same Einstein, so instead of 1 Newton, now I am changing the amount of force. Okay? I am changing the amount of force. Consider 1 Newton force is applied on Einstein towards south. 2 Newton force is applied to Einstein towards east. 3 Newton is applied towards north. 4 Newton is applied towards west. 1, 2, 3, 4. Okay? So I have a question to you. How much is the net force? How much is the total force on Einstein? Okay? This is a very challenging question. You may not be able to answer right away. Please do not worry. Please do not worry. If you can answer this question by the end of the class, that's my hope. That would be fantastic. Okay? Let me repeat the question. 1 Newton force, there are 4 forces acting simultaneously at the same time. At the same time. So you can think of something like this. Suppose you are standing, you have 4 friends. So one of your friends, all the 4 friends are pulling you. Just like this. With 1 Newton force towards south, your friend number 1. Your friend number 2 is pulling you. With 1 Newton force towards east. Your third friend is pulling you towards north with 3 Newton force. And your 4th friend is pulling you towards west with 4 Newton force. Right? So what is the net force on you by your 4 friends? Make sense? So there are 4 forces. 1 Newton by your first friend towards south. 2 Newton by your second friend towards east. 3 Newton by your third friend towards north. 4 Newton by your 4th friend towards west. How many forces? 4 forces. Right? On you. Okay, on you. At the same time, I'm not telling you that one applies 1 Newton and goes away. No, I'm not asking that. At the same time, simultaneously, at the same time, there are 4 of your friends who are applying 4 forces. 1 Newton to the south, 2 Newton towards east, 3 Newton towards north, 4 Newton towards west. So the question is, what is the net force on you, right? in what direction, what is the magnitude, how much is the net force. So this is a real challenge question. I ask this question to my students in my class. When I start to teach in the first class, for example, when I teach the topic of vectors, I ask this question. Okay, this is a very challenging question. If you really understand this question and answer this question correctly, you understand a lot of vectors. You understand a lot on vectors. Okay? So that is my question. So now let's do a simple experiment. Okay? Since I am talking with you, I don't want to go out of camera. So if you are multiple of you watching me, maybe two, you and your parents or multiple friends, please do this experiment. So what do is you stand up in right around there in your room and start walking. But please follow the rule. Please do not walk randomly. Please do not walk randomly. Please follow the rule. What is the rule? Okay. So what is the rule? The rule is this. So instead of myself, I am using Einstein. So Einstein has the footstep length, which I can measure, is about 3 centimeter. The length of the footstep is about 3 centimeter. Okay. You can measure your footstep length. If you ask me, my footstep length is about 25 centimeters. Okay. Okay. So Einstein's footstep length is about here about 3 centimeters. Okay, my little Einstein. So what do I do is, see, please follow the rule. Please stand up. Okay, please stand up. If there are multiple of you in a group watching me now, one of you please stand up. Okay, face towards north. Look towards north. Okay, please face towards north and then take one step towards north. Okay, and then turn towards east. Turn towards east and move one step towards east. Okay, so what did you do? Starting from some rest point, right? You stepped one step towards north and turn around towards east and made one more step. How many steps did you walk? How many steps? 2 steps, right? 2 steps, because starting from here, 1 step and then turn around and then one more step, 2 steps. So now here is a question. How much distance did you travel? That's very easy. That's very easy. 1 plus 1, which is 2. But instead of doing that, if you go back to the same original position, and now face towards the final position. Final position means you reached before. Okay? And then now, please try to walk in that direction. Can you reach the final point by walking 2 steps? Can you? Do you understand my question? Start from some point, 1 step north, turn around towards east, 1 step to the east, right? So you walk total 2 steps. Now go back to original point. Now you will not be turning towards north or turning towards east. Turn towards the final point and then now try to walk. Okay? Can you reach the final point you reached previously by walking 2 steps? Can you think about that? I mean, not think, you did that. You did that. Okay, let's try a different experiment. So what you do is, start from the initial point. Again, start from the initial point. Go 3 steps. Go 3 steps towards north. 1, 2, 3. Go 3 steps towards north. You did? Good job. Now turn towards east. Now go 4 steps towards east. 1, 2, 3, 4. right? You reach the final point. So how many steps did you walk total, starting from the original point? How much? How many steps? How many steps? 3 plus 4, which is 7. Now let's do something. Please go back to starting point. Please go back to starting point. And then now, please target to your final point. Not towards north, not towards east, but at an angle towards, target your final point. And then now, please try walking. Right? So 3 plus 4, right? You walk 3, you walk 4, so 3 plus 4 is 7. So now walk a certain number of steps. How many steps do you need to reach the final point? Is this 7 steps? Or it is different number? See, this very simple example tells you a lot about scalars and vectors. Right? So for example, let's consider this particular example because I get a whole number for that, not a square root thing. Okay? So start from the beginning, 1, 2, 3 towards north, and then turn around, 1, 2, 3, 4, right? So what you do is, there is a theorem called Pythagorean theorem, right? So what you do, you square 3, you square 4. What is 3 square? 9. What is 4 square? 16. What is the total? 25. Take the square root of that, 5. So now please try from the starting point to the final point. Can you try? Can you reach the final point by 5 steps? Okay. Now let's go back to our physics concept, that is vectors. Now I talked about 2 quantities here, right? So walking towards north, 3 steps. Walking towards east, 4 steps. Right? Walking diagonally from starting point to final point. Right? So here there are 2 ideas, 2 concepts in related to vectors. One is vectors and scalars, by the way. There are 2 quantities. What is one quantity? One quantity is distance. How many steps did you walk in total? Starting from the final starting point to final point, 3 steps towards north, 4 steps towards east. So total is 4 plus 3, 7. So that is the total distance you traveled. But you could have reached the final point more efficiently. More efficiently means covering smaller distance. How many steps? Just 5 steps. So now let me try to connect this idea. Okay. So I have some pencils here, right? I have some 3 pencils here. Okay, I have 3 pencils here, right? So these are of equal length. So let's go back to our first example. Let's say this is towards north, right? 1 step, like so. We can measure in centimeters, by the way. For your calculation, let me do in centimeters. So it is about 17 centimeters. So 17 centimeters that way. And this one towards east, another 17 meters. Now this is the starting point, final point, and then go towards east like that. Now what I was talking about is start from here and go that way diagonally, right? And 17 centimeters doesn't work. It has to be more, or it is not like 17 plus 7, 34 also, neither of that. So what do? 17 square plus 17 square and add together, right? And take the square root. So that is the straight distance. So like if you consider only one direction, like for example towards north, from starting point to final point, this length is scalar quantity. But once you specify the arrow, with arrow you specify the direction, that is a vector quantity. Right? So a quantity which has both magnitude and direction is a vector. For a vector, we need both magnitude and direction. For example, if you go back to our experiment, you started from here, right? some point, and then went towards north by 3 steps. So that 3 steps is a scalar. It is simply a distance, right? For example, for Einstein, 3 steps is equal to how much? Each step is 3 centimeter. So 3 times 3 will be 9 centimeter. So Einstein walked towards north 9 centimeter. You can divide by 100 to convert into meter. 9 centimeter, right? So that is the distance. That is a scalar. So Einstein walked in the first part of the journey. Little Einstein walked 9 centimeter or 3 steps towards north. If you say 9 centimeter, Einstein walked 9 centimeter, that is distance covered, and that is a scalar. But if you say Einstein traveled through 3 steps or 9 centimeter towards north, then that is a vector. That is actually displacement. Einstein got displaced by that amount. So this is the difference between vector and scalar. It looks simple, but life is not that easy. We need to learn a lot of things. Okay? So now, so let's continue with our example. 1, 2, 3 that way. 1, 2, 3, 4 that way, right? Towards east. First towards north and then towards east, right? So what is the displacement from initial point to the final point? Right? So from initial point towards north, right? That is 3 steps towards north. We know both magnitude and direction, good. So if you go towards east, 4 steps towards east, we know that. But here is the problem. If we consider starting point, right, and then the final point, and if you are doing experiment, if you are doing experiment, you are moving from initial point to final point diagonally, not towards north, not towards east, but along different line. You are targeting to the final point from the starting point. So now you already knew the magnitude, right? 3 steps squared plus 4 steps squared. 3 steps square is 9. 4 steps square is 16. 16 plus 9 is 25 square root. So that is how much? 5 steps from initial point to final point. Okay? But here is the thing. The 5 steps is the net distance. I mean the magnitude of the what we call the displacement between initial and final point. But what angle? What direction? How do you do that? So I asked you, if you have scientific calculator, that would be great, right? So please do a calculation. What you do is, so divide 4 by 3. Please divide 4 by 3. Please divide number 4 by 3. And if you have scientific calculator, please take tangent inverse. If you are little children, please take help of your seniors, your parents, your sisters, brothers, teachers, whoever around you. So 4 divided by 3, right? 4 divided by 3. Okay, let me do with you. Okay, so 4 divided by 3 in my calculator. 4 divided by 3, right? And then take the tangent inverse of the tangent function, right? So that comes to be 53.1 degrees. 53.1 degrees. What way? What way? East of north. You are neither going towards north nor towards east, but you are going 53.1 degrees east of north. Hopefully I did correctly. Let me do one more time. So 3 squared, the distance towards east was 4. The distance towards north was 3, right? So inverse tangent 53.1 degrees. Please check in your calculator. I hope I did correctly. So here, if your teacher asks you in class, what is the displacement? What is your displacement? What is your net displacement when You start from some point, go 3 steps towards north and 4 steps towards east. What is your net displacement in this journey? So your answer should be 5 steps. That is incomplete. 5 steps at an angle of 53.1 degrees east of north. You are neither going towards north nor towards east, but you are going along diagonal, right? So that's what you do, okay? Right? So now with this information, now you can think of that question which I asked in the beginning. 1 newtons to the south, 1 newton towards north, right? The force, I'm talking about force, that is a vector quantity. So if you are considering a force of 1 newton towards south, a force of 1 newton towards north, 1 newton towards west, and 1 newton towards east, what is the net force? Right? So things are easy if you are considering one direction only. So you can simply add, like for example, 1 newton towards south and 1 newton towards north. So those are two forces of same magnitude but opposite direction. So you need to add those two vectors. So you will not say 1 plus 1, 2. 1 newton towards south, if you say that is positive, 1 newton towards north, that is negative. So the sum is 0. 1 newton towards west, 1 newton towards east. So one is plus, other is minus. The sum is again 0, right? So if somebody applies 1 newton force on you towards south, towards east, not somebody, like there are 4 people, let's say, 4 people, one applies 1 newton towards south, other applies 1 newton towards east, other applies 1 newton towards north, other applies 1 newton towards west. So the net force on you is not 4 newton. The net force on you is 0. But on the contrast, let's do something. I have this apple, right? It has 100 grams or 0.1 kilogram. So suppose I put 10 apples in a bag, right? 10 apples in a bag. So you don't need to worry about the direction when you consider the mass. So 10 apples, 0.1 plus 0.1 plus 0.1, or you can consider in grams, 100 grams plus 100 grams plus 100 grams. You simply add. So that is the distinction between a vector quantity and scalar quantity, right? So what kind of quantities, what are those some quantities which are scalars? Like length of object, length of an object is a scalar, right? Length of an object is a scalar. Okay, time is a scalar, mass is a scalar. If you are students of higher classes, electric potential is a scalar, magnetic potential is a scalar. What are the vectors? Displacement is a vector, velocity is a vector. How about speed? Suppose you are driving motorcycle or driving car, a number is shown in the speedometer. What is that number? That's the speed, and that is a scalar. But if you are saying that I am driving like 20 km per hour towards east, that is velocity, which is a vector, okay, which is a vector. Acceleration is a vector, okay. Force is vector, momentum is vector. If you are students of higher classes, electric field is vector, magnetic field is vector, okay. So this you need to know this concept when you start learning physics. So then you can solve problems correctly, right? So now my challenge question, please think about that. My challenge question, you have 4 friends, you have 4 friends. One of your friend is pulling you towards south by 1 Newton. Next friend is pulling you towards east by 2 Newton, 1 Newton, 2 Newton. And the third friend is pulling you towards north by 3 Newton. Your fourth friend is pulling you towards west by 4 Newton. So what is the magnitude and direction of the net force on you? Okay? if you simply add all those numbers, so I would be unhappy. You didn't understand anything. So now from today onward, please be very careful on that. 1 Newton force, which is equivalent to the weight of 1 apple, towards that direction, right? 2 Newton force towards east, which is equivalent to the force or the weight of 2 apples. Somebody else is pulling you towards north, equivalent to 3 apple size force, 3 Newton. And the fourth friend is pulling you towards west, right? That is 4 Newton. So what will be the net force on you? And that, if you understand that, you can do a lot of things. You will calculate the net force, right, in terms of magnitude and direction. And suppose there are no other forces, right? Your 4 friends are pulling on you. Okay? These ideas are very useful in, for example, in everywhere. Like, so I'm just introducing concept here, but consider tug of war. Suppose there is a game of tug of war. How do you win that? So you need to apply force to win tug of war. Make sense? Okay, now let's go back. So what you do, your job this week is this. Please find the net force on you applied by your 4 friends, right? So you will calculate the net force, and suppose there are no other forces, right? Then you start from rest. Initially you are standing. Now, because of that net force, you will move in the direction of force. You will accelerate in the direction of force. So please, if you have measuring device, please measure your mass. How many kilograms are you, right? So you divide force by mass. That will be your acceleration. And that is a vector quantity. And that acceleration is in the direction of the force. See, that's the application of Newton's second law, F equal to ma. This is the beauty of physics, right? Without doing experiment, you can predict. You first predict, right? What do physicists do? They make models, they predict, and then they do experiments, right? So this is your job for this week. So with that, please wait for my next episode. Physics is Fun, episode 6, next Saturday. Okay. If you are enjoying my lessons, please comment. If you have, your feedback is really important. For example, some of you said that I am going a bit faster. I have tried to slow down today so that everyone will be in page, understand. Okay. And also some of you said that, it will be good if you have a whiteboard. I am trying to use the lowest possible technology to communicate with you. Of course, I can make high quality videos if I try. Okay, so I'm thinking about that in future. Okay, so please give your feedback to me. And I have gotten many requests in my Facebook. Unfortunately, I cannot add more than 5,000 friends. So I have opened a page just to communicate with you. Physics is Fun with Dr. Rudra Kafle. So you can visit that page, right? You can join that page even if you cannot join to be my friend, right? All of you are my friends. All of you are my friends. So thank you so much and namaste. Have a good night in Nepal. Have a good day elsewhere. Thank you so much.